A decorative door can leave finishing in perfect condition and still arrive with a visible corner rub, dust mark, or scuffed face. The damage may appear during delivery, but the weakness often begins earlier. Incomplete film coverage, a loose sealed edge, unstable roller contact, or an unsupported transfer after shrinking. Selecting a heat shrink packaging line therefore starts with the actual door and its route, not the machine name. Record the smallest and largest representative panels, their thickness, edge geometry, glazing, hardware, protective skins, and weight distribution. Document whether each product enters face up, face down, on edge, or on a carrier. Then map every contact point from finishing through conveyors, roller tables, manual lifts, storage racks, loading, and transport. Surface construction changes the packaging requirement. Painted, veneered, laminated, PVC-faced, foil-finished, high-gloss, glazed, and mirrored products can respond differently to heat, pressure, friction, and film contact. Existing protective layers must also be included in the assessment. Shrink film is one part of the protection system. It should not automatically be treated as a replacement for other surface protection materials. Before a factory trial, define what an acceptable package looks like. Specify the required coverage, sealed edge condition, inspection method, and permitted variation. Check the finished face under consistent factory lighting. Inspect edges manually, and examine framed or glazed areas for pressure marks. Most importantly, continue the test beyond the tunnel exit. Review the panel after shrinking, pressing, cooling, unloading, staging, and route representative handling. Film thickness alone does not determine protection. Buyers must also verify film width, overlap, clarity, storage condition, shrink behavior, sealing response, and compatibility with the decorative surface. Heat settings, conveyor speed, cooling behavior, and seal appearance should be recorded for every accepted sample. Testing more than one representative panel helps show whether the result is repeatable rather than unusually favorable. A practical readiness matrix assigns 3 priority units to surface vulnerability, 3 to package stability, 2 to line compatibility, 1 to safety and maintenance, and 1 to utilities and consumables. Each factor can be marked ready, conditionally ready, or unresolved. A standard door may pass while a glazed model remains conditional. That finding calls for another sample trial, not approval of the entire product range. The same evidence-based method can be applied to the EMANPACK SW-DP-01. Its published configuration includes upper and lower film spools, a heat sealing blade, shrink tunnel, 2 side press rollers, PLC and HMI controls, photoelectric detection, and adjustable conveyor speed. These features become useful only when tested against real products. Sensor response, mode changes, stopping and restart procedures, speed adjustment, roller alignment, edge stability, and post-cooling appearance all require verification. Site power, compressed air, ventilation, guarding, access, and conveyor interfaces must also match the intended installation. Final acceptance should connect the factory result to site operation. Approve the sample set and inspection criteria in advance. Retain photographs, product identification, film details, operating settings, orientation, conveyor speed, handling sequence, and corrective actions. Include records for emergency stops, guarding, cleaning, maintenance, safe access, and isolation procedures. After installation, repeat the acceptance check whenever the site layout, connected equipment, or product mix differs from the factory trial. This creates a traceable decision based on surface condition, package stability, line fit, and delivery performance, rather than relying on a neat-looking package at the tunnel exit.